So what do we really need to know about microphones? There's three technical characteristics that distinguish microphones from one another: the transducer type, the directionality or polar pattern, as well as its frequency response. These three things play a huge role in how the microphone sounds and the application it gets used in. In general, there are two types of microphones. On one side, we have dynamic microphones, and on the other side, we have condenser microphones. A condenser microphone has a diaphragm and an electrically charged backplate. Sound sets this diaphragm into motion, and any changes in this electrical field create your audio signal. There's one thing that we need to keep in mind about condenser mics, and that's that you need phantom power to operate them. Phantom power is typically provided by your mixer or mic preamp. A dynamic microphone has a slightly different design. It's more simple, but it's a very robust design. It consists of a diaphragm and a voice coil and a magnet. This voice coil is directly attached to the rear of this diaphragm. So when sound sets this diaphragm into motion, the voice coil moves in the magnetic field, and this creates your audio signal. Another kind of dynamic microphone is the ribbon mic. The ribbon mic also employs a diaphragm and a magnet, but no voice coil. So how does that all affect my sound? Well, the condenser microphones and ribbon microphones sound more natural, and this has to do with the fact that the diaphragm can respond to sound faster, and this provides higher sensitivity as well as more detail in your high end. Omnidirectional microphones pick up sound evenly from all directions. Just like my lavalier microphone here, I can move my head left and right, and it still picks up the sound. This can be really helpful because I don't have to aim this microphone in a particular direction. Okay. But using an omnidirectional microphone on a stage may not be such a good idea. Because of the other microphones, other instruments, or even your monitor wedges, all of these would simply create too much noise that the microphone would pick up, and this would result in feedback. So on stage, we want to use a directional microphone, for example, a cardioid. A cardioid polar pattern will pick sound up from the front of the microphone, but reject sound on the rear of the microphone. Because I can isolate the sound source, this results in a lot less feedback. A supercardioid polar pattern has an even narrower pickup pattern in the front of the microphone as compared to a cardioid. But it will also pick up some sound in the rear of the microphone. This is something that's very important to keep in mind when placing your monitor wedges on stage. If you're using a cardioid, you can place the monitor directly behind the microphone, but if you're using a supercardioid, it's always suggested to place the monitors just slightly to the left and right of your microphone. A bidirectional polar pattern is slightly more unusual. A bidirectional microphone will pick up sound from the front of the microphone as well as the rear of the microphone evenly, but reject sound from the sides of the microphone. Bidirectional microphones might be seen in television interviews or stereo miking. A flat frequency response is typically used in applications where you want to pick the sound source up as natural as possible, for example, recording. A tailored frequency response, on the other hand, is always tailored for a particular application. In the case of a vocal microphone, the mid-range might be boosted to allow your vocals to cut better through the mix, whereas with a kick drum microphone, I may want to boost the low end to give you a bit more punch.